Use properties of similar triangles to solve for a missing side. So similar figures means we have the same shape, but a different size. So look at these two triangles. This tells us that corresponding sides have the same ratio. So corresponding sides AB, and then let's just say CD and EF. So if we were to create ratios, we would say A is to B, as C is to D, as E is to F. So as fractions, they would all reduce down to the same exact fraction. And then corresponding angles are equal measure. So we know that in the case of a triangle, the sum of the three interior angles has to add up to 180. So that's the same. So the corresponding angles are congruent. So this is also important to know when you have similar figures, because again, they're the exact same shape, just one is bigger than the other. Okay, so let's look at this. We're just first going to find the ratio of these similar figures. Now, it is really important that they tell you what is similar to what, because you might say, well, it looks like, yeah. In math, we don't use looks like. We only use facts of what actually is. So they tell us triangle ABC, is similar to triangle DEF. Now, that means because angle A comes first and D comes first, those would be corresponding angles. We know that angle B and angle E are both right angles because those are already given. And then C comes at the end and F comes at the end. So C is going to be congruent to angle F. Now that we have that, we also can say sides. So we know that side AB is going to be a ratio to DE. So AB to DE. So we'll go 8 to 12. And then we know that BC and EF, so that's 6 to 9, and AC, DF, so 10 to 15. Also make sure, notice that all of the ABC triangles are in the numerator, all of the DEF triangles are in the denominator. That is important to note. So now, each one of these, 8 over 12 reduces to 2/3, 2/3, 2/3. They all reduce to the ratio of 2/3. So that would be the ratio from ABC to DEF would be 2/3. So if we would say if this triangle DEF had a length that was 3, that means in triangle ABC the length would be 2 because that's the ratio 2 to 3. Okay, now let's find some missing pieces. Triangle MNO is similar to triangle PQR. Find the values of X and Y. Now, I'm a big fan of putting in what I know first. So, M and P. So I go M, P, because these are going to help me work, especially if you got like color and color works for you. Angle N is the same as angle Q. So N and Q go together. And then O is similar to R, right? So O and R. So when I do that, this allows me to know that PQ corresponds to MN. So I know I have the ratio 14 to 10. And you might say, well, why is that important? Well, it's important because then I look at QR, which is X, corresponds to NO, which is 14. And now I can solve this proportion to find X. So remember when we solve proportions, we cross multiply. So 14 times 14 gives me 196. And 10 times X is 10X. So I divide both sides by 10. And my value of X is 19.6. So this length is 19.6. Then we do the same thing for Y. So you'll note I still have the ratio 14 to 10, right? PQ to MN. Always use what's given. And then I could say, okay, P to R is Y, M to O is 16. Again, you want to make sure you're staying consistent. So the triangle PQR is in the numerator and triangle MNO is in the denominator. That's important. So now we cross multiply. Okay, so 14 times 16 gives me 224. equals 10y. Divide both sides by 10, and my y value is 22.4. Now, one thing I always like to do is use common sense. You'll notice that MN is the smallest side on that triangle, so that the corresponding side PQ should be the smallest side in the triangle. Similarly, MO is the longest side, so that means PR should be the longest side. Those are just common sense things to say, okay, just make sure that the numbers make sense where I have them. And that's how we can use similar triangles to find missing sides.